Hello everyone, my name is Ahmed Mohamoud Ali. I'm from Software Department, Section 3. Today I will present my research on containerization and virtual machine security, efficient trade-offs. So this research explores the fundamental trade-offs between security and efficiency when deploying application in modern cloud environments, focusing on experimental comparisons between Docker containers and KVM or kernel virtual machine. Understanding this dynamic is critical for format enterprise deployments. So, uh, this challenge, they need both higher performance for rapid scaling and robust security for protecting sensitive data. So, this creates critical tension. There are many things, or we can say this challenge have main points. For example, DevOps teams used or rapid deployments, scaling multiple updates per day. Security teams need strong data isolation compliance with HIPAA or health insurance, portability and accountability. So the question is, can we both, can we have both or must we have uh, choose between speed and security? So this is what my research investigates. The critical tension between agility and isolation. So uh, this is the uh, virtual machine. So virtual machine, uh, we can say is like uses for hypervisor, like hypervisor software, like VMware and also KVM or kernel virtual machine or Hyper-V. Well, that sits between uh, the hardware and the operating system. Each VM or virtual machine runs its own complete operating system. So also the virtual machine has main points. For example, stringent isolation. Each virtual machine completely separates at hardware level. If one VM compromised attacker cannot easily jump into others. So why this is question, very important question. So why banks and hospitals uh, use VM or virtual machine? The answer this because virtual machine has uh, superior security. So and also virtual machine has weakness. So each virtual machine needs full operating system, means high memory usage. Start Startup time. The uptime of a virtual machine is 25 seconds booting entire operating system. So we can say each virtual machine is like a separate house. So strong isolation, but significant overhead. So next, container. Container also is very important because container probability popularity by Docker and orchestrated by Kubernetes. Container take a completely different approach. Instead of virtualizing hardware, they virtualize at the operating system level. So what also we can say the containers has main points. Like all containers share the same operating system kernel. Use Linux namespace and C group for isolation. What's the analogy for container? So analogy for container like apartment is a building shared foundation, separate units, and also has strength, incredibly lightweight. Also, startup time for container is 2 seconds. Uh, like 2 second startup. Just starting a process. There is no like booting operating system. While the virtual machine using booting operating system. So the critical point is or critical security for a container is all containers share same kernel. If attacker is compromised, kernel can escape container, access the other containers or host a system. That is called container escape attack. Why? So this is the research methodology. This is very important because to unparallel these technologies, we need to recognize experimental conditions or we use it the identical hardware setups both with virtuals, CPU, and 16 gigabytes of RAM. As you see here, there are two types, or we have two things, experimental setup or evaluation tools. Like experimental setup are hardware and virtual machine environment, container environment. Also evaluation tools, performance benchmarks or security assessments. Uh, the important thing is all we use mean values to ensure accuracy. So we also measured baseline performed on like bare metal or hardware to normalize our results. So identical hardware standardized tool is repeated experimental for occurrence. So uh, this is performance results. So performance results like container consistently outperformance the virtual machine across all uh, performance indicator demonstrated significant efficiency. So this is container outperformance virtual across like every efficiency metrics we measure. So first one, CPU throughput. Container achieve 135,000 operations per second compared to virtual machine as 100,000. So that is 35 percentage performance advantage, meaning you can process more transactions with the same hardware. Second one, memory utilization. Memory utilization container used only 502 alif megabytes per workload versus 760 megabytes for virtual machine. So that's 32% less memory in a cloud environment where you are like buying per gigabyte. This translates to significant cost saving. Third one, input and output. Container uh, container peaked at 350 megabytes per second for disk operations, like 40 percentage 40% faster than virtual machine, 250 megabytes. So megabytes per second. So this is crucial for data intensive applications. Fourth one is start up time. So, but perhaps the most striking difference is start up time. Containers launched in approximately 2 seconds, compared to 25 seconds in a virtual machine. That's a 92 percentage instances for this difference is 95. No, just I can say 92 percentage reduction in micro surfaces environment where you might be scaling up dozens of instances. This difference is crucial. The last one, energy efficiency. Energy efficiency, finally, energy efficiency containers consumed 0.89 watt hours. So per task versus 1.42 for virtual machine or VM. That's 37 percentage better energy efficiency in large data center. This impacts both operation cost and environmental sustainability. So, from pure performance perspective, containers are the clear winners. Container winner we can say that this is security assistant results. Isolation is key. Virtual machine constantly provide stronger security posture, particularly in term isolation and kernel protection. So, but performance is not everything, you know. Let's look at the security, and here the picture reverses completely. Virtual machine score 4.5 out of 5. In our overall security assessments, while containers uh, scored only 3 out of 5. So let me break down why. For isolation, boundary strength, how well workloads in uh, separate virtual machine scored perfect 5 out of 5. So the hypervisor creates like uh, hardware level. So uh, that's a little bit a barrier that extremely difficult to breach. Uh, Container is scored only 3 out of 5 because namespaces like while effective are software-based isolation within the same kernel. So even more concerning like is kernel level protection VM or virtual machine is scored container is scored just 2 out of 5. So because uh, they all shared the host kernel. Vulnerabilities in that shared kernel could compromise all containers on that host. So important thing is no container security can be improved using advanced sandboxing solution like V or G visor or Kata containers can bring the container security up of about like 4 out of 5. So, however, and this is important, this hardening techniques reduce of like performance by 10 up to 15 percentage. So you are giving back some of those efficiency gains to improve security. So this highlights the fundamental trade-off in our research. Virtual machine provide superior isolation. Shared kernel is containers. So this is key trade of analysis. As you see, this picture is like security and efficiency. So if you see the security has putting strong isolation and higher resources overhead. Otherwise, efficiency has lightweight resources and increasing attack surfaces. So this slides visualize our important our central finding. There is inverse relationship between security and efficiency. You cannot maximize both simultaneously. So containers give you lightweight resources and incredible efficiency, but at the cost of increasing attack surface due to the shader kernel, an attacker who compromises one container could uh, potentially perform. Container escape to access the host or other containers. Like virtual machine give you strong isolation, you know, through hardware virtualizations. So, but you pay for it with higher resources overhead, more memory, more CPU cycle, and more energy consumption. This is not a flaw in either technology. It is fundamental architectural differences. The equation is not which is better, but rather which trade-off is appropriate for my use case. Yeah, that is the point. So let me give you like concrete example. Let me give you concrete example. For example, if you are running a social media application where you need to scale or quickly to handle traffic spikes, the performance benefits of container probably outweighs the security risks. But if you are processing credit card transaction or patient medical records, the superior isolation of virtual machine or VM is non-negotiable, even if it costs more. So inverse the relationship you must choose based on your priorities. Deployment recommendation. So here there are three things: container for agility, virtual machine or VM for security critical, hybrid approaches. So how could the organization make this decision? Let me provide practical recommendation based on uh, this question. So I want to give you the what you appropriate for you to use. So use container when you agility it is your priority. This includes microservices architecture where you are deploying hundreds of small surfaces. CD or ID. CD means CI. I mean CI or CD. CI means continuous integration. CD continuous delivery. So pipeline is for CD or CI pipeline is where you are constantly testing and deploying code and DevOps environments where you need and resources efficiency are critical for container Excel here because you can scale from 10 to 1000 or 2000 instantly in seconds, not minutes. You know, not it is seconds, not minutes. So otherwise, use virtual machine for security critical. application. This includes financial service, handling transaction, healthcare system with patient data, and any compliance bound environment with regulation like BCI or DSS or HIBA or health insurance portability and accountability. Here, the superior isolation form of virtual machine justifies the highest cost. Uh, hybrid, hybrid approach. But there is a third option that is increasingly popular. Hybrid approach, major cloud providers like AWS or Fargate or and Google Cloud runs actually run container inside a lightweight virtual machine. You get the developer experience scaling characteristics of container, but the virtual machine grade isolation underneath. This is the best of both worlds through its DAS at same complexity. The sophisticated approach is not choosing one over the other. It is using the right tool for each workload. So the strategic selection based on requirements, not one size fits all. Okay. Last page. This is conclusion page. So first, container deliver undeniable for performance advantages like 25 up to 40 percentage better efficiency across the board, but virtual machine provide superior security with 4.5 out of 4.5 versus 3 security score. Secondly, the this is fundamentally strategic decision. Organization must align their technology choices with their primary objectives. If you optimize for speed and cost, choose containers. Okay, if you optimize for isolation and compliance, choose virtual machine or VM. Okay, for future direction, looking forward, the industry is actively working to bridge this gap. Technologies like Firecracker, micro VM aim to provide virtual machine level security with near containers performance. Hardware-based trust extension environment use specialized CPU feature to create secure evaluates. Advanced sandboxed containers are improving isolation without sacrificing too much speed. Future research should also examine these technologies in distributed multi-cloud architectures where application span multiple cloud providers. Final statements, I said the security efficiency trade-off will likely persist, but emerging technologies are narrowing the gap. So thank you for listening.